Welcome to the championship final. Listen, you have exactly 90 minutes to glory. That is your entire window. 90 minutes on the clock to execute your game plan for Cambridge Mathematics exam victory. Today, we are diving deep into an explainer that decodes exactly what examiners are desperately looking for when testing the exact values of trigonometry. Whether you're sitting for syllabus codes 0580, 0606, 4024, 4037, 4040, 9231, or our main focus today, 9709, this strategy is your absolute blueprint for success. We are looking specifically at concepts that bridge across multiple syllabus codes, taking you from the foundational elements all the way to advanced mechanics. But to understand how to win, we first absolutely need to look at how students often lose marks. I want you to picture two candidates. First, take Alex. Now, Alex overloads with raw mathematics facts. Alex spends hours memorizing every single formula, every single identity, but applies absolutely no analysis in the exam hall. Alex just throws numbers at the page, hoping something, anything, sticks for the examiner. Then there's Sam. Sam is the classic rusher. Sam rushes through the paper and completely misses the critical command word requirements, calculating a long, messy decimal when the examiner explicitly and specifically asked for an exact value. So what is the final result when the grading happens? Alex loses all the crucial method marks for a complete lack of structure, and Sam loses the accuracy marks for completely ignoring the requested format. It's heartbreaking, really. But today, we are going to learn exactly how to build a fortress around your marks and avoid those exact pitfalls. Let's get into it.
Here is our game plan for today. We are going to break this down into 5 structured parts. 1. Core principles of trigonometry. 2. Exact values made simple. 3. The step-by-step method. 4. Securing crucial method marks. And finally, 5. Top examiner warnings revealed.
Let's kick things off with Section 1, Core Principles of Trigonometry.
Now, what is really fascinating about the insights on your screen is that the examiners themselves explicitly state that integrating your knowledge across different syllabus areas is the absolute key to unlocking top marks. Let's be real for a second. When you're dealing with exact values of sine, cosine, and tangent for 30, 45, and 60 degrees, you cannot view them in isolation. It's not just a standalone topic. These exact values are literally the connective tissue of the entire mathematics syllabus. You are going to need them in coordinate geometry when you're asked to find the exact angle of a straight line intersecting an axis. You are going to need them heavily in calculus when you're integrating complex trigonometric functions and substituting limits. You will absolutely need them in mechanics when you are resolving tension and friction forces on an inclined plane. The examiner is not just testing if you know a simple table of numbers, they are rigorously evaluating if you can deploy that knowledge seamlessly into a multi-stage cross-topic problem. This is exactly where our friend Alex fails, by treating math like disconnected flashcards instead of an interconnected system. Before we continue,
Okay, let's talk about assessment objectives. These academic benchmarks prioritize analytical depth over superficial breadth. They focus heavily on your logical, structured reasoning. The Cambridge command words are your literal roadmap here. If a question says state, well, they just want the exact value. Simple. That is pure knowledge and understanding. But if that command word shifts to show that, or hence evaluate, you are immediately entering the higher-order domains of application and analysis. Top-tier students structure their answers to hit all these domains using a numerical adaptation of the Peel framework. You might know Peel from English class, but it works wonders in math. Point. Identify the exact trigonometric principle or identity required. Evidence. Extract the precise exact value needed from your memorized toolkit. Explanation. Show the step-by-step algebraic manipulation, leaving nothing to the imagination. Link. Tie that final simplified surd or fraction back to the specific context of the question. Your brain needs to shift gears through these cognitive domains fluently. You make your point, you back it up with mathematical evidence, you explain the steps, and you link it to the answer. That is how you secure maximum marks every single time.
Moving right along to Section 2, Exact Values Made Simple.
what you're seeing here brilliantly illustrates your core mathematical toolkit. Knowing these exact values for 30, 45, and 60 degrees is an absolute non-negotiable for the syllabus. But look, let's trace the origins of this data so it is not just blind, panic-induced memorization. If you just memorize, you'll freeze like Sam does under pressure. Instead, let's build it from scratch. Imagine a perfect equilateral triangle. Every side has a length of 2. Now drop a perpendicular line straight down the middle from the top vertex to the base. Boom! You've just created a right-angled triangle. Because you split it, the angles are now 90, 60, and 30 degrees. The hypotenuse remains 2, the base is now exactly 1. Using our good old friend Pythagoras, the vertical height is the square root of 3.
From this single simple geometric construct, you can derive every single exact value for 30 and 60 degrees using basic SOHCAHTOA ratios. Want the sine of 30? Opposite over hypotenuse. The opposite side is 1, the hypotenuse is 2, it's 1/2. How about the cosine of 30? Adjacent is root 3, hypotenuse is 2, root 3 over 2. It really is that logical. Now for 45 degrees, picture a different shape. Picture an isosceles right-angle triangle with two shorter leg lengths of exactly 1. Using Pythagoras, the hypotenuse is the square root of 2. Therefore, the sine and cosine of 45 degrees are both 1 over root 2. And remember, we rationalize that to root 2 over 2 to make the examiners happy. The tangent of 45, well, that's opposite over adjacent, 1 over 1, which is just 1. Understanding this derivation gives you a reliable, bulletproof anchor when exam panic sets in and your memory goes blank.
Now, if memorizing that table or mentally drawing geometry feels way too overwhelming when the clock is ticking down, you need to leverage this specific memory hack. It's time for the famous hand trick. This is a game changer. Hold out your left hand right now, palm facing you. Let your pinky finger represent 0 degrees. Your ring finger is 30 degrees. Your middle finger is 45 degrees. Your index finger is 60 degrees, and your thumb is 90 degrees. Okay? Now, whenever you need to find the sine of an angle, simply fold down the finger that matches that angle. Count the total number of fingers below the folded one, take the square root of that number, and divide the whole thing by 2. Let's test it. Want the sine of 60 degrees? Fold down your index finger. Look at your hand. There are exactly 3 fingers below it. So, square root of 3 divided by 2. Done. What about cosine? For cosine, you fold the finger, but count the fingers above it, square root, and divide by 2. It is a highly effective, totally foolproof visual mnemonic. It ensures you never ever have to rely on a calculator's decimal output when the command word explicitly demands an exact surd format. No more losing marks because you panicked and wrote down 0.866.
All right, let's power through to Section 3, the step-by-step method.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get into the workshop. Systematic processing follows this strict 5-step sequence. This ensures you extract relevant data and use the correct notation every single time. Step 1. Identify key elements. What is the command word? What is the given domain for the angle? Step 2. Apply principles. Which trigonometric identity actually links the information given? Step 3. Execute analysis. This is where you substitute your exact values and perform the algebraic manipulation carefully. Step 4. Verify results. Does your answer fall within the required quadrant based on the CAST diagram? Step 5. Present format. Ensure your final answer is rationalized. Now, it's time for Challenge 1, Data Scan. I'm putting 60 seconds on the clock right now. Look at the complex math data source on your screen. You need to extract the core trend. What is the examiner actually asking for here? The clock is ticking. You have to scan the text, bypass the fluff, and identify the exact command words. Are they asking you to solve, to state, or to show? Look at the domain constraints. Is it 0 to 360, or is it 0 to 2 pi? Time's up. If you correctly identified that the question requires an answer in radians, not degrees, you are already thinking like a top-tier candidate.
Let's dive right into Section 4, securing crucial method marks.
It is a high-stakes scenario we literally all fear. You're 90 minutes into the exam, you reach the end of a massive calculation, you draw a line under it, but your final answer is just completely wrong. So, do you lose all the points? Let's consider a scenario where a student writes out a brilliant substitution using exact values, but in the third line of their working, they accidentally drop a negative sign when moving from the second quadrant to the first. They simply forgot that cosine is negative in the second quadrant. It is an incredibly frustrating mistake. Let's do Challenge 2, Find the Flaw. I'm putting Sam's flawed paragraph on the screen right now. You have just a few seconds to spot the exact sentence where Sam loses the marks. Scan it closely. Where is the algebraic mistake? Right there. Sam substituted positive 1/2 instead of negative 1/2. But here is the critical examiner commentary. Did Sam score 0 for the whole question? Absolutely not. Not even close.
The examiner alert is crystal clear on this. Method marks can save your grade. The grading framework heavily rewards the process and the systematic analysis, even if the final result is flawed. If a math question is worth 5 marks, the final accuracy mark, the A mark, is often only worth 1 single point. The other 4 points are method marks, known as M marks, and independent B marks.
By systematically writing out that Peel framework we discussed earlier, stating the identity clearly and substituting the exact value correctly, you literally lock in the M&B marks immediately. Think about our characters. Alex, who just writes a final wrong answer with 0 working, scores a big fat 0. Sam, who rushes and uses decimals instead of exact fractions, loses both the method and the accuracy marks. But a strategic student? A strategic student builds an impenetrable safety net under their overall grade. Which brings us to challenge 3, speed writing. You have a 30-second timer to write out one perfect Peel paragraph setting up a trig equation. Go. State the identity. Show the substitution. Just write the setup. Even if you don't solve it, you just secured 2 out of 3 marks. That is how you play the game.
Finally, we reach Section 5, Top Examiner Warnings Revealed.
Let's look directly into the examiner's playbook. This comparison shows that higher-order assessment demands true evaluative thinking. Top candidates actively questioned assumptions and considered different perspectives, rather than just blindly crunching numbers. Let's decode exactly what this means for you. Superficial evaluation means seeing an equation, finding one single angle that works on your calculator, writing it down, and moving on. That's a huge trap. Top-scoring candidates look much deeper at the domain. Is the domain set between negative 180 degrees to positive 180 degrees? Are we working in radians? A massively common pitfall is doing the entire exact value calculation perfectly in degrees, but totally failing to realize the examiner specified the domain in terms of pi. If the domain is 0 to 2 pi, and you write 60 degrees instead of pi over 3, you lose the mark. You absolutely must question your assumptions before you underline that final answer. You justify your decisions by showing the explicit algebraic link between the step where you utilize the exact value and the final solution you provide. It's about proving to the examiner that you didn't just guess.
You need to avoid these 3 exact pitfalls pulled straight from the Cambridge Principal Examiner reports. Mistake number 1, confusing cause and effect. In trigonometry, this often looks like mixing up an inverse function with a reciprocal function, or applying an identity backwards without any mathematical justification. Secant is 1 over cosine. It is not the inverse cosine. Don't mix them up. Mistake number 2, forgetting to check format and presentation conventions. Guys, this is the ultimate tragedy. You know the exact value of tangent 30 is 1 over the square root of 3. You write it down perfectly. Your math is flawless. But the question explicitly said, express your answer in the form a root b over c. Because you rushed and you didn't rationalize the denominator to root 3 over 3, you completely lose the final presentation mark. It is entirely avoidable. Mistake number 3, providing answers not specific to the given context. If a mechanics question asks for a tension force using an exact trigonometric value, you must provide the appropriate units, like newtons. If you just leave it as an abstract fraction, the examiner cannot give you full credit.
As we wrap up this championship strategy session, you have to ask yourself a serious question. As you prepare to apply this framework to past papers, will you just try to memorize the math like Alex, or will you master the method to secure every possible mark? Mastering the structural Peel framework, decoding command words, managing your time, and questioning your domain assumptions, these are the things that dramatically shift your grade. The exact values of sine, cosine, and tangent are your essential tools, sure, but your analytical structure is your true advantage. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.